Hi there, this is video 615 and I call this the RWIN diagram, and it just does the final touches on our linear inequalities to make sure you're graphing them incorrectly. So take a look at those top two graphs. Don't get freaked out, please, but look at this and look at that one. Okay, I want you to find the difference. Yeah, you got it. Right? This one has a less than sign, and this one is less than or equal to. That's the only difference. Now, for the record, I'll read this out and we will go through this again, so don't freak out. All right, so these squiggly brackets, that means a set. And you've seen that before when we did Venn diagrams, right? You know, you're familiar with set notation. All right, so this is a set of points, and the points are an X and a Y. And they got the brackets. Well, it's just telling you this is about a graph. So it's a set of ordered pairs, and that line means such that. Okay, now, so hey, pay attention. Basically, pay attention. We're doing a graph. We're gonna have some points, and pay such that. So here's what we're gonna do. There's the actual graph we're worried about, and then it says X is an element of R, Y is an element of R. R, real numbers. Okay, way back there was that crazy diagram with all the squares or circles in it, and natural numbers. That's coming back. That was chapter 1, maybe chapter 2. Mostly chapter 1 when we did that types of numbers. Maybe the introductory stuff too. All right, but anyway, all I care is that this is a less than sign and this is a less than or greater than. Now, I want you to take a look at the two diagrams. And what's the difference there? Okay, don't go with the color of the shading. That's not important, but I hope you can see that this is a dotted line and this is a solid line. Remember when we started inequalities and we had a graph, put up here, X is less than 6. So you would go, there's your 6, and you'd put a circle around that, so that's saying I don't include 6, and it would go like that. And then we said if we had X is less than or equal to 6, you would do the same diagram. There's my 6, except you would color it over to show that 6 is included as part of the solution. Well, when you're drawing the line, this is what they do. So a dotted line means that the line itself is not part of the solution, whereas if it's a solid, the line itself is part of the solution. So this one or this one, it doesn't matter whether it's a less than or greater than. What you need to do is you draw a dotted line. Line is not part of solution. When you have a less than or equal to or greater than or equal to, you draw, let me just write it, a solid line. And in this case, the line is part of the solution. Solution, or I should be writing it right, feasible region. Okay, so that's the first thing that's really important. Dotted line, solid line. And why wouldn't you do that, right? It's a really simple thing to check on. Now let's look at these last ones and take a look at what the difference is. Now, if you look closely at the graphs, they're all exactly the same. But what's the difference in the drawing? Yeah. R, W, So when it's x is an element of R, that means x is a real number, which means real numbers, if you remember, is like kind of any number you can think of, positive, negatives, rational, irrational, decimals, anything is fine. You know, any point you put is good. So I'm going to use this because it's exactly, whoops. Okay. So I keep using the same diagram. So I know it's, I'm not going to do a checkpoint, but I know it's this part. So if it's a real number, you get to, it doesn't have to be a highlighter. You can also scribble these in. There you go. So that means I can have numbers here. I could have an answer that's here. I can have that one, right? I can have one that's exactly on the line because remember equal to. Any of those dots in there work. When the question, when I forget, or when a textbook doesn't say anything about what kind of numbers, the domain and range, right? Domain, oh, I'm not sure we've done that. So this refers to domain. So your x values, what values can I use for x? And this is your range, the y value. Okay, so what values are okay with what? So real numbers, you get to shade everything, get to color. All right, so this, exactly the same question. So we know our answers are gonna kind of be above the line, but this is whole numbers. Oh, hold on for a sec. You see down here? Real numbers. All right, shade it in. And it's the only time you get to shade it in. It might be helpful. Real life example is, I don't know, you're mixing two solutions or something, and you can use 2.5 liters of this and 3.25 liters or something like that. Not so good if you're talking about cats and dogs. All right, so W stands for whole numbers. How's the memory? Whole numbers start at 0, and it's like 1, 2, 3, like that. So if we are restricted to whole numbers, I can't, this one right there is no good because it's got a negative in it. Right down here, I don't know what it is, but those are no good. So with whole numbers, we're restricted to our first quadrant. So our answers have to be in here, and we're also not allowed to have partials. So this would be a good example, like how many cats and dogs are in the shelter? Well, you don't have 3.4 cats, okay? No. So what you end up doing is you end up doing dots. And the dots can go because 0 is part of it. So this coordinate, okay, maybe I should back up. This coordinate right here is 0 and 2. So if x is supposed to be a whole number, 0 is a whole number, yes. 2, yep. Let's say I pick this point. Well, that's got coordinates 2 and 1. Is 2 a whole number, right? Because x is supposed to be a whole number. Check. Y is a whole number. Yep. So all the way through here. Now that's on the line. I don't get to do that one because that's got coordinates. It's 5 over, but it's like a half up, so that's no good. And I can do this one and that one. Now, if these are pretty small graphs, if you had like a big graph, like a half page or something where you had to do this, you can just do like dots around the outside and then just write the word dots through the middle. Oh, and I should add to this, where am I going to put it? Dots. All right, integers. Integers. How's the memory? Yes, sign numbers. So negative dot, 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 -2, -1, 0, 1, 2. All right. It's not restricted to any quadrant, so you can be wherever you want. However, you are restricted to whole numbers, so it's like where the lines cross. And it's going to be dots again. So again, we're working with the original one where we know the answer is up here somewhere. So this is the correct side. This is the correct side. This is not so much. Okay, so integers. Okay. I don't know what I was. Oh yeah, that'd be part of my solution. I was getting all worried there. There. That's usually what I do is I kind of do an outline and then I just write down. Although, you know, if it makes you happy and you would like to sit there and go dot, dot, dot through the whole thing, you go right ahead. It's actually oddly therapeutic. That makes me kind of happy too. Whatever. Okay, I'm good. If, like in this one where you have dots in the first, second, third, well, I guess you have dots in every quadrant. It's not a bad idea to make sure you have a dot in each quadrant. So like you don't just stop with your dots with that much. I need to know that it's over there too. All right, last one. N, what was N for? N is equal to natural numbers. And those are your counting numbers. So 1, 2, 3. So they're almost the same as whole numbers, but you don't get to include 0. So first quadrant, no zeros. Excuse me. I'm going to be honest with you guys. For the most part, if you're doing some kind of word problem, it's either going to be whole numbers or it's going to be natural. Because if you're dealing with things -6 cats or -5 tables, it doesn't make sense at all. Okay, so no zeros. So I don't get to use I don't get to be on the axes. And again, it's dots. So it's only when you're doing real numbers, sorry, it's cold today, that you get to worry about shading. Otherwise, it's dots. So if you're not sure, go with dots. 3 times out of 4, you'll be right. And then you just have to worry about the quadrants you're going to be in. Okay, so that is the dreaded RWIN diagram. This is really important. Something you should memorize, or at least something that you make sure you don't lose. Okay, cool. End the video.